This is an introduction to surds and irrational numbers. So let me write down some examples of surds. If we write down the root of 4, we can show that that is equal to plus or minus 2, because 2 multiplied by 2 is equal to 4, and negative 2 multiplied by negative 2 is equal to 4. Now the square root of 2, there doesn't exist any integer which will multiply to give 2. So the square root of 2 can be approximated, and we can write down the square root of 2 as 1.4142135622. Now we define this as an irrational number. Now we can multiply 1.4142135622 by itself, square, and it will still not give 2. It will give a number very, very close to 2, but not 2. Some calculators may give that as 2, but they're approximating the answer. Okay, so let's give another example. The root of 3, the root of 5, the root of 6. And the rule is, if we are square rooting a non-square number, the result is a surd or an irrational number. Now you may say to me, well, what about the square root of 8? That can be written as 2 root 2. Well, still, root 2 is an irrational number and therefore a surd. So let's write down our definitions then of a surd and irrational numbers. So a surd is a square root value which cannot be simplified further. A surd produces a non-terminating non-repeating decimal. So let's look at some examples. The root of 2, the root of 3, the root of 5, the root of 6, the root of 7, the root of 8. There are infinitely many surds. An irrational number cannot be written as a fraction. That is to say, cannot be written as a over b. An irrational number is non-terminating and non-periodic. That means non-repeating. So irrational numbers go on forever, and they do not repeat in cycles or blocks. They're not periodic. Okay, so from the list there, can you identify the surds? Pause the video and see if you can identify the surds. Okay, so this is equal to 11, this is equal to 8. So the surd values, definitely 72, definitely 90, and definitely 28. So let's get rid of that. 72 gives a surd value of, we should write an abbreviation there, an approximation rather, 8.4852 goes on forever. The root of 90 gives 9.4868 goes on forever, and the root of 28 gives 5.2915. Okay, so pause the video and see if you can decide if each of these is rational or irrational. Remember, if it can be written as A over B, it is rational, and if it cannot be written as A over B, it is irrational. So pause the video. Okay, so this can be written as 22 over 5, so it's definitely rational. So we need three numbers, three of the same numbers, to give -8. So those numbers are -2. So -2 can be written as -2 over 1. So this is definitely rational. This is irrational because it gives negative. My calculator, negative 2.645715.311 goes on forever, and that is an abbreviation. This can be written as 2 over 3, and this is irrational again because it does not repeat. Okay, so these surds are real numbers. They can be represented on a number line as shown in the diagram, and we've got some special surds there. Pi is an irrational number. The root of 5 is an irrational number and a surd, and we've got them represented there on a number line. Now I just want to go over 0.6 reoccurring is the same as 0.66666 goes on forever. Now we can write that as a fraction by letting x equal 0.666666 reoccurring. 10x then would be 6.666666 goes on forever. If we subtract the 2, if we call that 1, we call that 2. If we subtract 2, we get 9x's. Now, these cancel out. Does everybody see that these cancel out if we subtract them? Just to get 6. And if we solve that, we get x is equal to 6 over 9, which is equal to 2 over 3. Okay, so let's have a look at an exercise. Okay, so decide which ones of these are rational or irrational. Let's get rid of this. Okay. So pause the video and decide which of these are rational or irrational. Okay, so you should have done that now. I'm just going to pop the answers on the screen. Okay, so these are the answers. If you can mark your work, and if you need some extension work to do, why not show that 0.4 reoccurring is the same as 4 over 9, and 0.7 reoccurring is 7 over 9, and why not prove that root 2 and root 3 are irrational. Okay, so that finishes our introduction to surds and irrational numbers.